Hello and welcome back to Flip Class. Today we're going to talk about energy in the Earth system. We're going to talk about what energy is, what forms that we have of energy, and what are sources to the Earth of energy we have, and how the energy actually moves within the Earth system.
Alright, so first things first, what is energy? And that's a little bit tricky question to answer. Even professional scientists have a hard time defining this term really simply. But for our purposes, we're going to talk about energy as related to action, as related to movement. So anytime that there's motion or an activity, there's energy involved in that. And energy is then what is needed to make anything happen.
So we have a little example here of an experiment. We're trying to move a toy boat with a fan. So of course we need to have some energy to make this happen. So we're going to turn the fan on, which causes the blades of the fan to move and spin, which creates air. This moving air goes and impacts the sails of the boat, causing the boat to move. And of course when the boat moves, it makes waves. And all this is a transfer of energy from the fan through the air to the boat and into the waves. But let's back up a little bit because we have to get this fan going. This particular fan works on batteries. And these batteries here store the energy until we're ready to turn the fan on to use. Now these particular batteries are rechargeable batteries. So we can plug them into our electrical wall outlet here and give them the energy that they need to store. And when we're ready to use them, we turn the fan on, which converts this chemical energy that was stored in the batteries back to electricity, which starts the fan, and the whole process keeps going. So this whole process started back at our electrical wall outlet.
So if there was energy in the electrical wall outlet, it had to come from somewhere, and that's what we're going to look at now. We're going to go back to the source of that energy. And there was the energy that was electricity in the wall outlet was this electricity that was moving through wires. So that motion, we don't usually think about motion in electrical wires, but there is motion there. There's current moving through the wires. So that's energy. And if we trace that energy back through the wires, we find out it's coming from this crazy place. We're going to break this down. This is a power plant. And our wires were connected to this power plant. And they were connected to this setup, which is a turbine and a generator. And basically, this turbine is moving around on this shaft. And that motion has energy in it too. And that energy came from steam that was pushing the fans of this turbine around so it would rotate. And that steam, we know, has energy in it because it's moving too, right? We know that steam rises, so there must be energy in steam. And that steam came from boiling water. Well, water, when it's boiling, there's the bubbles coming up out of it. That's motion. So there must be energy in boiling water. And that energy, you know, comes from heat. Think about a pot of boiling water on a stove. So that heat is energy too. We don't usually think about heat as motion, but it is. And you can see that motion when the heat is coming from an open flame. So here we have flames that are moving around, so they're showing that there's energy going into the water, making it boil, which makes steam, which makes a turbine move around, which we can use to make electricity moving through the currents. And that's how a power plant works. Well, what were those flames from? They were burning coal, we see here. And coal is a rock. Well, rocks don't move, so can there really be energy inside of them? Well, yes, there's energy being stored inside of this coal. And we can think of it kind of like energy being stored in those batteries in that last slide. And that energy had to come from somewhere. Well, how would energy get in coal? Well, we talked about with the carbon cycle that sediment and rocks can come from living things. And that's what happens with the coal. That burial and sedimentation occurred. So hundreds of millions of years ago, there were plants that died, got buried, and they turned into coal. And those plants had energy stored in them, and they gotten their energy from the sun. So if we trace back from this electrical outlet, the energy that's in that electrical outlet originally came from the sun.
So speaking of the sun, we know that the sun is our major source of energy, and it's an external source, meaning that it's not coming from within the earth, it's coming from outside of the earth. The energy from the sun is in the form of radiation. We've all heard of radiation before, but what exactly is that? It's energy, and it travels through space. So in other words, we don't have to be touching the sun to get that energy from it. Light and heat and sound are all types of radiation. The radiation that comes from the sun comes to the earth as light. Now some of this is reflected back into space, but much of it does come in and impacts the earth on the earth's surface.
So, another external source of energy on earth is the tides. And tides are an external source because they have to do with the moon. And the moon has a gravitational pull. It's not strong enough that we can feel it, but it's strong enough that it actually affects our oceans. So when our water in our oceans is closer to the moon, it's getting pulled towards the moon. And as water builds up on the side close to the moon, water is getting pulled away from other parts of the earth. So that's what we call tidal motion. And here's a picture that shows it. So this is at high tide, when that tide is closer to the moon, or when the water is closer to the moon, rather. And here's a picture at low tide, when this part of the world is farther away from the moon, so it's having water pulled away from it. And this is in a place called the Bay of Fundy, where the difference between high tide and low tide is extreme, right? So if we look, this is the same boat that's floating on, I don't know, maybe 10 feet of water, that right here is sitting on the ground. So that's a lot of motion that's represented, because sometime between these two pictures, all that water rushed away from this place. And that motion is energy. There's actually so much motion in that movement of waters between high tides and low tides that people have thought about collecting it. We put turbines underwater, like the ones that people use to collect wind power. You could move those turbines around and turn that energy of the water rushing past it from the tides, you can turn that into electricity.
So now we're going to talk about some internal sources of energy on the earth. Internal meaning that the energy is coming from within the earth rather than from outside of the earth. One of these is called geothermal activity, and what is happening here is we see a geyser down here where we have water and steam shooting out. Geo means, you know, the land and the earth, and thermal actually means heat. So inside the earth, we have a lot of heat generated in the core, and this water that's underneath the crust is being heated up from inside the earth, and it's basically erupting kind of like a volcano would to the surface of the earth. So on the right here we see sort of a picture of what's happening inside the earth. In the middle, that dark part is the core, where it's super hot, and around it where you can see the movement happening is the mantle. And this is basically molten rock, and it's circulating around because of that heat. And a lot of times we can see evidence of this when our volcanoes erupt and that magma that has been moving around in the mantle actually comes to the surface of the earth.
Alright, another internal source of energy is radioactive decay. And what radioactive decay means is that there are certain types of atoms that don't want to stay the way they are. They want to break down. And we can see an example here of what's called a radioactive atom, and it's breaking apart. This particle is coming off of it. It's breaking off. And when that particle breaks off of that atom, there's some energy release because there was energy being used to hold that particle into the atom. So when the particle is gone, that energy to hold it in isn't needed anymore. The energy actually escapes on its own. It's just free energy going through the air, and that's called radiation. We talked about radiation coming out of the sun, and now we can talk about radiation coming out of these radioactive atoms. But it's only specific types of elements that have these radioactive atoms, and the most common ones on Earth are uranium and plutonium. And these substances, you won't find like a pile of uranium somewhere. You'll find these radioactive atoms of uranium spread out through rocks. So they would look something like this. Here's a picture of a dump truck that's hauling away crushed rock, and the rock has these radioactive atoms spread out through it.
One more internal source of energy on the Earth is gravity. We talked briefly of gravity when we were talking about the moon and its effect on our oceans and the tide system. Gravity, of course, we're very familiar with gravity because we know that it causes things basically to fall. So gravity, even though it's a force and we don't necessarily think of it as energy, the force of gravity is creating movement. And so what's happening in this top picture here is an avalanche. So all the snow and ice that was on top of the mountain is being pulled down by the force of gravity. Same thing is happening with our earth slides. The force of gravity is causing the rocks and the soil to be pulled off the mountainside down into the road here. And finally, the force of gravity also works on our rivers and our waterfalls. All this motion that's happening with the water and it's flowing over the edge and falling is due to the force of gravity.
Alright, so to review, let's just look at these statements for a minute and make sure that you understand them. And if you don't, you can rewind and go back to the presentation and make sure that you do understand them. If you still don't after you've reviewed the video, make sure you bring questions about them to class tomorrow. Because these are the things we really want you to take away. So one is, energy is part of any action. Anytime something's moving, there's energy. And energy moves between different forms. So the same energy can go from one action into a different action. And then the major sources of energy on Earth include the sun, which is by far the biggest source of energy, and then also tides, geothermal activity, radioactive decay, and gravity. So thanks for watching.